This is the practice test walkthrough for Chapter 6 on the periodic table of elements. So the first 12 questions can be answered using the letters on the periodic table above the questions, and in several cases there are 2 correct answers. In some cases there are only 1 correct answer. So I'm just going to walk through and give you the either ors or the correct answer if there's only 1. So question 1. The element is considered an alkaline earth metal. Well, alkaline earth metals are the ones in group 2, so that would be this column here. So either B or G would be correct for that. Question 2, an element that has 1 valence electron. Well, the elements with 1 valence electron would be the elements in the first group, which would be either M or C. Question 3. This element has an electron configuration ending with D. Well, electron configuration ending with D would be anything in the D block, which is this middle section of the periodic table. So either L or A would be correct for number 3. Number 4, this element has the largest atomic radius in its group. So what you have to remember here is that the atomic radius tends to increase as you move down within a group, which means the one on the bottom of a group would have the largest radius. So there's only one right answer for number 4 because there's only one element at the bottom of its group, and that would be E. Question number 5. This element is the heaviest natural element in the universe. So you have to remember, first of all, that the heaviest natural element in the universe is uranium. Uranium is in the 3rd group in the bottom row of the F block, which makes it this element here. So the answer there is D. There's only one right answer for that. Number 6, this element has a full outer shell of 8 valence electrons. Well, that means that it's in the noble gas group. So there's only one answer here, and it's I. That's the only one in that group. This element has the highest electronegativity of all elements. That's number 7. The highest electronegativity of all the elements is fluorine, which in this case is J. This element is a metalloid. That's question number 8. And remember that the metalloids go down following this zigzag line. So the only element that's on that line in this case is element F, which would be silicon. Number 9. This element has properties similar to calcium. Calcium is in the alkaline earth metal, so it would be an element in the alkaline earth metal family. So there are 2 correct answers here because calcium is in between B and G. B would be magnesium, G would be strontium. So either one of those would have similar properties to calcium. Number 10, which element is an inner transition metal? The inner transition metals are the elements in the F block down at the bottom here. So either D or H would be correct for number 10. Number 11. This element has 5 valence electrons. You have to remember that the elements with 5 valence electrons are in group 15, which is this group right here. So either N or E would be correct there. And finally, number 12. This element has electrons in the F sublevel. Again, we're talking about F sublevel. That means the F block. And technically, there are 3 correct answers because the F block goes in these 2 rows. So you could say that L or D or H all have electrons in the F sublevel. D and H end their electron configurations in the F sublevel. L doesn't end, it ends in the D sublevel, but it does have some electrons in its F sublevel. Number 13, according to the law discovered by whom, there is a pattern of repeating properties with every 8th element. So this is what's called the law of octaves. And it was discovered by John Newlands, letter B. Dmitri Mendeleev took Newlands' work and built on it to make his periodic table, and Henry Moseley came after Mendeleev. So it went Newland, Mendeleev, Moseley in that order. Lothar Meyer is not somebody we have talked about. Identify the period and group numbers of the element with the electron configuration noble gas Ar 4s2 3d10 4p1. So to look at that on the periodic table, we're talking about P, so it's in the P block. It's got a 1 up here, which means it's going to be in the first column of the P block. And it's 4, so 1, 2, 3, 4 would be here. So it's going to be this element. So the question is, what is the group and period? Well, it's period 4, and overall it's group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Period 4, group 13. Answer choice B. Which of the following observed properties is the most reliable when classifying a substance as a noble gas? Well, any gas is not a good conductor of heat. Noble gases do have low melting temperature, but there are other elements that have low melting temperatures, so that's not the best measurement. All the noble gases are very unreactive with other elements, so that's probably it. And then if you look at this, crumbles when hit by a hammer, well, gases aren't going to do that. So the answer here is C. Which correctly describes elements in the same period? So that's the same row. Same number of valence electrons? No, that's elements in the same group. They have electrons in the same outermost energy level. That's definitely a possibility. They have the same atomic radius? No, atomic radius changes. And must be in the same state of matter? Absolutely not. There are gases, liquids, and solids in the same period in some cases. So, answer B. 17. What is the most important characteristic in identifying elements, elements with similar properties? Number of protons? No. The period that it's found in? No. Total number of electrons is not what defines the properties. The number of valence electrons, answer D, is the characteristic that defines properties of an element. Okay, which group will have an electron configuration that ends in NP5? And the N here just means for it could be any number from 1 to 7. So we're looking at the P and the 5. P means it's going to be in the P block, and the 5 means it's 1, 2, 3, 4, fifth column within the P block, and that group, which is group 17, has the special name halogens. So that's answer C. How many valence electrons does oxygen have? Well, where's oxygen? Oxygen is here on the periodic table, so we have to figure out what group is that. So it's in group 16, but that's not how many valence electrons it has. When you're talking about these elements over here, group 13 to 16, you look at the second digit. It has 6 valence electrons. If you did out the electron configuration like this, you might think it has 4 because that's the ending, but that's not all of the electrons on the energy level. And it has a total of 8 valence electrons, so that's not right. The answer here is D. Which property describes the ability of an atom to attract electrons of other atoms in a bond? The atomic radius is the size of a neutral atom. The ionic radius is the size it has when it forms an ion. The electronegativity, that is the element's ability to attract electrons. Ionization energy has to do with how much energy it takes to get electrons away from an atom. So that's C. Okay, 2 questions referring to the same diagram. Which diagram above correctly depicts the trend in atomic radius? Well, atomic radius generally increases from top to bottom, so it would be one of those, not that, not that. So it's either A or C, and we say that atomic radius generally decreases from left to right. So the correct answer there is C. And for number 22, which is the general trend in electronegativity? Well, electronegativity generally increases from left to right, so we can cross off those two, and it generally decreases from top to bottom, so the answer here is B. So we're trying to identify an element based on some properties here. It has similar properties to oxygen and selenium. Oxygen and selenium are both group 16, so it's going to be in that column. And it has an atomic number greater than krypton. Krypton is here, and less than iodine. Well, iodine is this element here. So if you start with krypton and you go over until you get to that column with oxygen and selenium, you find this element here, which is tellurium. These are all about understanding the trends in the periodic table. So electronegativity increases as you go from left to right across a period. So if you look at nitrogen and oxygen for number 24, oxygen is farther to the right, so it's going to have the higher electronegativity. Which has the greater radius? Well, we've got two chlorine atoms, but one of them, this one over here, is an ion, and it's a negative ion, and you have to remember that the negative ion of an element is always larger than the neutral atom of the same element. Which element has the greater atomic radius? Well, atomic radius tends to decrease from left to right, and this is the one that's farther to the left, so that's going to be bigger. Which element has a greater ionization energy? Well, ionization energy increases from left to right, so which one is farther to the right? Neon. Neon is a noble gas. They have very high ionization energies. Which of the following has a smaller radius? Again, we've got two calciums, but one is an ion, so which is going to be smaller, the neutral atom or the positive ion? Positive ions have lost electrons, which means the remaining electrons get pulled much closer to the nucleus, making the overall size smaller. The element with the smaller ionization energy is going to be the one farther down in its group, because it tends to decrease as you go down, so that's going to be iodine. And which of the following has the greater radius, cesium or lithium? You need to know that atomic radius increases from top to bottom, which means the one farther down in the group. Cesium in this case is always going to have a greater radius. Explain why fluorine has a higher ionization energy than boron. Fluorine is farther to the left, so that is the trend, but the reason that it has a higher ionization energy than boron is because when you've got the positive charge in the nucleus, and you've got electrons around the outside. Now, fluorine and boron both have their valence electrons in the second energy level. Fluorine has more electrons and more protons. The protons all get added in here. The electrons are being added out here to the outer ring, but they're not being added any farther away. The protons in the middle are able to pull the electrons in closer, and the closer the electrons get to the center, the stronger the attraction is between the protons and the electrons. If another atom wanted to come along and take those electrons away, it's going to be much harder to get that electron away than it is for boron, whose electrons are farther away. It's much easier to grab one of those electrons that's farther from the nucleus than it is to get one that's closer in. So fluorine has a higher ionization energy because its electrons are held more closely to the nucleus. Explain why rubidium has a lower electronegativity and a larger radius than sodium. Okay, and it's the same reason for both, and it's similar to what we just discussed with fluorine and boron. So rubidium is a big atom. It's got a lot of protons and electrons. Sodium is a smaller atom. Okay, they're in the same group. They're both alkali metals. They both have one valence electron. But remember that electronegativity is when atoms are trying to pull on the electrons of other atoms. And they pull on the electrons of other atoms with the nucleus in here. Well, another atom, again not to scale, but here's another atom coming along. It can only get this close to the nucleus of a rubidium atom. It can get a lot closer to the nucleus of a sodium atom. Here's sodium, here's rubidium. So the nucleus of the rubidium atom is not going to be able to pull on these electrons as strongly as sodium is, because sodium's nucleus can get closer to those electrons. Rubidium's radius is bigger because it has more energy levels, more layers than sodium does. So the electrons on the outside are farther away. That makes it bigger. So rubidium has a larger radius because its outer electrons are on higher energy levels, and it has lower electronegativity because any electrons it's trying to attract are going to be farther away from the rubidium's nucleus. Okay, why does atomic radius decrease from left to right across the period? Same reason we've been talking about. Every time you move from left to right across a row, you're adding a proton to the nucleus and an electron to the outside. But the protons are all concentrated in the middle, and the electrons are being added to that same outer level, so they're not getting any farther away, which means that the protons can kind of gang up and pull those extra electrons in tighter. And as the electrons get pulled in tighter, the radius decreases. Why do noble gases have no measurable electronegativity? Well, remember, all the noble gases have that N2P6 8 valence electrons. Electronegativity is about atoms pulling on other atoms' electrons, because some atoms are trying to gain electrons to get 8. They all want to have 8 valence electrons. Well, noble gases already have 8 valence electrons, so they have no interest in taking electrons from other atoms. So noble gases have no measurable electronegativity because they have a full outer shell of valence electrons. Why does the first ionization energy tend to decrease, moving from top to bottom within a group? All this stuff is related to the same things we've been talking about. Here's an atom. Here's another atom from the same group. Okay, this first atom, let's just say it's got 1 valence electron. That's what we're talking about with the first ionization energy. And this one over here has another one. Well, this electron, which is from the top of the group, or near the top of the group, and this one is near the bottom of the group, its outermost electron is very close to its nucleus, so it's going to be held tightly. Even if it's not as tightly as other elements, it's going to be held more tightly than this electron, which is 3 layers farther out and much farther away from the nucleus. So this nucleus over here can't hold on to this electron as tightly as this nucleus holds that one. So the ionization energy decreases from top to bottom because outer electrons are getting farther and farther from the nucleus. Oldies but goodies. Convert 5.40 grams to milligrams. Well, 1 gram is equal to 1,000 milligrams. So 5.40 times 1,000 equals 5,400 milligrams. How many protons, neutrons, and electrons does potassium 40 have? Well, the 19 at the bottom, that's the atomic number, which is equal to the number of protons and the number of electrons. The number on top, the 40, is the mass number, and that's the protons plus the neutrons. So then you can do 40 minus 19 to find out that the number of neutrons is 21. Counting significant figures. Okay, so the first one here, we've got 8.43000. So do these zeros count? They count because they are trailing zeros after that decimal. So this has a total of 6. 52000. Do these zeros count? They do not, because there's no decimal point over here, so this number only has 2. Alright, over here we've got 0.001034. How many of these zeros count? Well, these zeros do not count because they're to the left. This 0 counts because it's a sandwich 0, so there's 4 there. Okay, same type of question here. You've got 2 zeros here, you've got a 0 here. These do not count because they're before the number in a decimal. But this one is a trailing 0, which does count, so you've got a total of 4 numbers there.